Hi there, so today I'm going to talk about feasibility, checking feasibility. What that means is checking that the projects that you want to do are going to work out for you in your home. And today I'm going to focus on thermal efficiency, what you can do to check out exactly what the thermal efficiency is of your home, different techniques that you can use and why that's important and what you can get out of it, and then what you can do from that. Okay, so I hope this is going to be an interesting video, and it's supporting the checklist that I have together, the Check It Out checklist, which you can use to check out your project, make sure it's right for you. So who am I? I'm Jane. I help homeowners who are eco-conscious to improve their homes, make them cosy and characterful, beautiful, fit for a modern lifestyle, but also planet friendly. And let's get into it. So a really key thing to check is what your existing structural or construction build-up is. So you need to know, what are your floors made of, especially your ground floor, what are your walls made of, your windows, your roof, maybe the top ceiling, and all of these things. The reason you want to know about this in terms of upgrading your home for thermal performance is because these form your external envelope. If you read up anything about thermal efficiency and insulation, then you will probably come across this term external envelope. And what it basically means is it's the layer of building, or the build-up of the building, that is between you and outside. So that is the ground floor, the walls, the windows, the external doors, and it could be the top floor ceiling, or it could be the roof. And those are basically the bits that envelop you or envelop the inside of the house and separate you from inside to outside. And what you want to know is, how good are those elements at retaining heat? And there are different ways to check that. So I'm going to get into those. So first of all, you can just have a look. What can you see? What are the materials that you can see? And if it's an older building, you probably don't want to do too much hacking into the walls, or pulling up or pulling down things to see behind and see what's there. But this might be the only way of actually finding out. So you want to, depends on how sensitive a property in terms of sort of historic value that you're working on. But if you're sort of like looking at your standard 1930s semi, then lifting a couple of floorboards and having a look underneath. You can even go as far as drilling a core, doing a core. I don't know what the term is actually, like a borehole. So drilling a kind of borehole plug and pulling that out, and then you can see actually what the whole of the construction, what's in there. Obviously only gives you a snippet of that construction at that point, but doing that kind of thing is really the only way to sort of see exactly what, say, a wall is made up of. But it's really destructive. I mean, it might only be a small hole, but you don't want to do that, for example, in a much more historically sensitive property. You don't want to be going drilling holes into the wall to see what it's made up of. So other things that you can do to check the thermal efficiency that are non-destructive are a pressure test. So what you'll find is that leakage of air is a way that you will really lose a lot of heat. So on older properties, just filling up gaps that will constantly crack. Buildings, you might think that your building stays nice and still and solid and steady, but actually all buildings move all of the time. It's just that they move so slowly that you don't notice. But all building materials will gradually move because they will absorb moisture, and that will make them expand. They'll lose moisture, that'll make them contract, and that happens with changes of season, changes of weather, and changes of what you're doing inside as well, because you might be producing a lot of moisture inside at times. So that is the main thing. It's the moisture that mostly does it, especially with timber. Timber moves an awful lot, and different types of materials move more than others. And so where you've got a junction between, this is slightly going off point, but where you've got a junction between two different materials, especially say for example you've got windows within a masonry wall, so the junction between the windows and the masonry will always be a little bit under pressure, and will often, you'll get cracking happening there. Say in the plaster work, particularly materials that are a bit more is friable, is that the right word, where you know they're more likely to crack and crumble, so, which is like plaster is. So though at those places you want to just continuously maintain filling, so that those cracks don't occur, or they will occur, but you're constantly maintaining them so that they're not letting air pass through in and out constantly unrestricted, because that air moving in and out is really losing you a lot of heat in the winter. And so one way that you can test how much air your house is losing through cracks and gaps in the external envelope is by doing an air pressure test. And what that is, they sort of seal the front door with a big sort of bag, and they push air into it with a fan, and then they just sort of check the pressure really to see, you know, how much pressure, how much airflow is going through, and then, you know, then you can also combine that with either just sort of smoke sticks. You can walk around with smoke sticks around typical places where you're going to get cracking, and then from outside you can see that smoke coming out through the cracks, so you can see where the cracks are. Or you can do thermal imaging, so you use a camera that can actually see differences in temperature. So you'll have probably seen those, they're like sort of multicolored, usually multicolored different pictures where you look really weird and very colourful and doesn't look like real life. It can be quite hard to interpret those pictures, so you really are best to, you can do it yourself, you can hire those cameras, but you're best to get someone who's a specialist who really understands what they're looking at and knows how to interpret that information better. But that combination of air pressure test and a thermal imaging test is a really good way for you to see where any cracks and air leakages are occurring. And then another way that you can use the thermal imaging is to see where there might be gaps in insulation, or there might be damp problems. So it will see where there's a differential of temperature across a wall, and often you'll get like little gaps, or insulation might have slumped a little bit, or somewhere it might have been on a bit of insulation being pulled out and then not put back in, so there's a space where there's no insulation there. Or you can equally see if plasterboard has been dot and dabbed on, then you'll get a movement around behind that, and there'll be more of a air is an insulator, so where there's no glue adhesive dabbed onto the wall, you'll tend to find that that bit of wall is warmer, and where there's a dab it's going to be a bit cooler because there's a bit more of a bridge between, so you'll get cold. Those dots will feel colder than around those dots. I don't know if this is making any sense. It would be helpful to see, to be able to show you images of that, but there are lots of images of thermal imaging. You can easily Google thermal imaging and see what different examples of different kind of errors, or like different places where you can get that sort of differential occurring, and then understanding why is that happening. And then once you've got that information about where your cold spots are and where your air infiltration is, you can also then do moisture testing, so in combination with the thermal imaging that can show you, for example, it can show you where, you know, your roof might be leaking, or where pipework might be leaking that you hadn't picked up because it might be just leaking at such a small amount that it's making the building materials around that area damp, but it's not really dripping through. It's not so noticeable that you can see the water, but you can possibly touch it and feels cold and damp to the touch, but it might not be so visible. But once you've got the thermal camera on it, it can really show up much more visible because it tends to be a lot colder. And so then you can also do a moisture test. So you can get moisture test meters that kind of like stick, know how they work. They kind of pass electric current through it, I think, and just see the resistance of the materials that it's testing to the passage of the electric current. That's what I imagine it does. So you stick that into the material and it can give you a reading, or onto the surface of the material, and it'll give you a reading of what the moisture content is. And if it's high, then you've got moisture, a lot of moisture, and if it's low, then it's not that, and it might be something else. So those are really the best non-destructive ways or non-invasive ways of assessing your thermal performance. And then another thing you can do is do like a SAP calc. Now they're not really that accurate and they tend to be quite indicative. It does depend on who does it. The person inputting the data into the SAP calc, SAP stands for Standard Assessment Procedure, and it's the only calculation that is recognised for building control. And so it's a government recognised calculation that you can use to assess the performance of your external envelope. And what you do is you input the information about the U values of the different build-ups. So U values is basically, it comes from a calculation of how resistant each layer within that build-up is to the movement of warmth across it, the movement of heat across it. So for example, in a brick wall, so you tend to have internally, you tend to have plaster, then like a really modern construction brick, so it'd be plaster board on dot and dab back to a concrete block, and then you'll have some insulation, and then maybe it may be a gap, or it might be a full fill insulation, and then you'll have external bricks. And so each of those materials will have different ability to allow heat to pass through them, and the insulation is obviously a poor conductor of heat, so it will slow down heat moving across it, whereas something like the facing bricks will be quite a good conductor of heat relatively, so they will let heat go through them relatively easily. And then there are other things that SAP calcs take into account. If you're looking at the overall U value of a wall, then you'd also look at things like the wall ties, because they often are metal and they form miniature cold bridges that go through the insulation. They tie together the internal brickwork to the external brickwork. This is all very technical and possibly quite boring for you, but this is information that is really important to know and understand if you want to start to look at improving the insulation or improving the thermal efficiency of your home. And actually, you don't need to know and understand all this if you don't want to, because you can employ somebody else like me to help you with this process as part of your project. But I'm just trying to give you a little bit of a flavour of the technicalities of these things. So The SAP calc, it's only really indicative because, especially if you are trying to do a calculation based on an existing building and perhaps you don't really know exactly what's inside that wall. You know, you can see the bricks from outside and the plasterboard inside, but you don't really know if it's concrete block or facing block internally. They're very different in their resistivity. You don't know how much insulation is there and what type is in there unless you do like a kind of a little core hole and get a sample, and then you can maybe find out. So all of these things tend to then become a bit indicative because you don't know. But then, you know, you look at your roof build up, your ground floor build up, and things to do with your windows and stuff, and then you gradually, that information is inputted into the calculator and spits out an amount, and that's what you'll see when you buy a home and you've got the energy performance certificate. The EPC is based on the SAP calc, the standard assessment procedure calculation. That's where it comes from, and you'll get graded, you know, A, B, C, D, E, whatever, about as how efficient your home is from an energy or heat point of view. So those are the kind of ways to find out what your existing home is, you know, at what point you're at in the existing home. And you might not be feeling particularly cold in your home. You might find that it's actually, you know, you don't feel any sensation of drafts across you when you're sitting in your living room or you're sitting eating your dinner. Or you might be the opposite. You might find that actually it is pretty cold, and even if you've got the heating on, it still can be a little bit uncomfortable, and you have to have the heating on for a long time, a high temperature, for it just to feel comfortable. And if that's the case, then you will definitely benefit from upgrading the thermal performance of your home. And these tests will help you to identify what you can do, what the most effective things that you can do to improve the performance. So this is why it's part of the feasibility process. It's this early stage process that you go to figure out, you know, what is it you do need to do to your home to make it work for you. And once you understand the existing situation, then you can start to figure out what it is you can do about it. So have you got a damp problem? Well, then can you fix the roof, or can you get a plumber in to fix the pipes? You know, whatever the damp problem is. Or do you need better ventilation? Maybe it's moisture from internal uses like cooking or showering, and you don't have adequate ventilation, and then you need to get ventilation to get that moisture laden air out of the house and stop it causing damage and potentially, you know, health implications from sort of mold and condensation and things like that can occur if you've got too much moisture in the wrong places. But these tests will help to identify that. So that's why it's really important to understand these things pretty early on, because then you can say, okay, well, we do want to be warm and comfortable and cozy in our home, like that. Most people want that. If you don't want that, okay, that's fine. But if you do want to feel warm and comfortable and cozy, well, there are different things you can do. Obviously, you can put another extra warm layer on, but if you want to just make your home comfortable, then understanding what the situation is now, where are you at, what's your base point, and then from having that information, carrying out these tests, air pressure test, thermal imaging test, moisture test, having SAP calcs done, all of that information can then help indicate and help you decide what you can do to improve your home from a thermal point of view. And then you can then incorporate that into your project, knowing that, you know, this is what we've got to do, whether that's we're going to add some insulation to the loft, or we're going to add some insulation to the ground floor, whatever it is. You can have that as part of your package of work that you want to do as part of your project, and you can allocate budget to doing that, and that way you can make sure that at the end of the day you've got you're going to be able to do what you want to do within the budget that you have set. And you can, this is part of the process. This whole feasibility stage is essential. It's the vital part of your project. If you don't do this bit, you can find that you really get to the end of the project and you've missed out on some real opportunities to make improvements to your home that sometimes are not going to cost that much, or just you could have just incorporated as part of your works that you were going to do anyway, and it wouldn't have cost you anything additional, or moderately, you know, only a moderate amount more, and you could really regret not having known that. But if you follow a really good feasibility process at the very early stages of your design, then you can incorporate it and you're going to be much less likely to regret what you end up with at the end, because you'll have it all in there. Next week I'm going to talk about other technical things, so other things that you can check, other surveys and things you can do, who you can get to do them, and all of that sort of thing. So that's it for now, and I will speak to you again next week. Bye for now.